Welcome back, everyone. Today we are going to be talking all about this guy, the camera. We're going to look at some of the different camera properties that we have and also what some of our options are when it comes to creating new cameras, looking at our objects from different perspectives, and things like that. So this video is kind of split into two parts. The first is what we can just do with the camera by itself, and the second one is the ability to add, or the second part is the ability to add what are called object constraints. And we're going to use object constraints to make cameras a little bit easier to deal with. This is one of those tricks that I always get a lot of blowback on because students always say, Mr. Smith, why couldn't we have learned about the camera constraints earlier? And the reason is so that you guys can get practice with the very basic tools in Blender before we start taking shortcuts. So, we can have more than one camera in a scene. And while this may seem counterintuitive, it's really great for looking at stuff at different angles and being able to preserve those angles. So I'm going to add a camera the same way I would add anything else. I'm going to either go to the Create tab and select Camera, or I can do Shift A and add a camera. So here's our new camera. And if I press number pad 0, we see that the scene is still being viewed from my first camera's perspective. See that there? That's because this camera, the first camera in the scene, is called the active camera. So I'm going to add some notes to our little camera section here. Multiple cameras. We need to change the active camera if we want to be able to view it from a new angle. And to do that, we click the new camera and we do Control plus number pad 0. This switches the active camera. So let's take a look at that. I'm going to click this guy, Control number pad 0. Now this is the camera from which I'm viewing the scene. And if I render image, we can see that because this camera isn't pointed at anything, my scene is just this dull gray color. So I'm going to rotate my camera around a little bit. I'm going to go down here. Some people have been asking me how to do this. We talked about it a long time ago in a different video, but I want to just bring it up again. This section here controls the different types of handles. So we have a transform handle, a rotation handle, and a scale handle. And I am going to be using the rotation handle to more easily spin my camera. So I'm going to move this guy around. Let's see if he's any closer. Almost. Tilt him down a little bit. Getting a little bit better. Let's look at a side view here and rotate him downward. Okay, now we can see the cube. So now if we render, we can see this close-up overhead view of the cube. And the nice thing about using cameras in this way is that it allows us to switch back and forth between different angles easily. So if I want this camera to render from its perspective, I can just do Control number pad 0 again, and I get this camera's view. What's really nice is if I wanted to create multiple renderings of the same object, I could just render this one, save it as an image, and then spin around to my other camera and render that one as an image as well. And that's sort of what you guys are going to be doing today, except I'm not going to ask you to hand in multiple images. So that's how we add multiple cameras. Let's talk a little bit about some of the properties that exist in our camera settings. So if we go over here to this thing on the button bar that looks like an old style video camera, that is going to open up our camera properties. And our camera properties have a few different things that we can check out. The first one is the type of lens that we can select. So let's take a look right now. This is what's called the perspective lens, and that's what's included by default. We can switch this to orthographic, which, just like orthographic view in Blender, causes my camera to scale everything back and kind of flatten everything out. So now the cube looks much flatter, the grid looks flatter, and that's orthographic view. And panoramic view is designed to give us a little bit more of the edges of our scene. It's not hugely different from perspective view, but it's supposed to give us kind of a fishbowl effect. So those are our three things there. An important one to remember that I actually want to write down for you guys is this focal lens. Focal lens, without actually moving the camera, focal lens changes the camera's width. So focal lens changes width. A lower value means a wider view. You can see that I'm dropping this focal lens way down and it's pulling my camera back. So I'm seeing more of the scene. If I bring the focal lens closer, it kind of acts like a zoom. That's one way that we can change the zoom level of our camera without actually moving our camera closer and farther. Shift is a little interesting. Shift moves the camera without actually changing the camera's perspective. So this allows me to shift the camera along its x-axis and then along its y-axis, kind of like the camera is on a pulley system or a clamp almost. So the camera is clamped in place, but I can shift my camera in different directions. Clipping is one of those ones that can cause a problem if we have a lot of stuff in our scene. So if far away objects aren't showing up, increase clipping. Clipping is the amount of area that we can see in our camera. By default, we can see just in front of the camera, almost 0, all the way out to 100 units. But if I put something in this scene more than 100 units away, I might not be able to see it. And if I drop this down to 10 units, notice now that I can only see this little bit of my cube, because only this little bit is within 10 of my camera. So I have drastically reduced the amount of distance that my camera can see. We'll bump that back out to 100, which is the default. But keep in mind that these are here, because it may be the case where you can't see something in your scene, and the clipping is what's causing that issue. We're not going to worry too much about the camera presets. There's a whole bunch of different cameras that you could select here if you wanted to. We're not worried about that, nor are we worried about sensor size. But depth of field is something that I also find a little interesting. Depth of field is how we achieve that blurred look that you sometimes see in movies. So if I put a circle, I don't want to do a circle. Let's get rid of that circle. If I put a sphere back here, and I put a cube, and we'll move that cube a little farther away. We'll move him kind of out here a little bit. And then I select my camera again, and I change the depth of field settings. This controls which section of my depth of field is in focus and which sections are blurred. So right now, if I render, everything is rendered equally. However, if I choose to focus on my first cube and then render, oh, that's not showing us a difference. I'm missing something here. All right, that's supposed to be blurring the objects behind it. I must have a setting missing, so if you guys want to do this in class, I'll make sure to review it. I'm not sure why it's not working here, but I also don't want this video to go on forever. So we'll revisit that once I figure out what setting I'm missing here. However, that would allow us to achieve that look in the movies where the foreground is not blurred, but the background is blurry. And then finally, we have some display settings here, which we could play around with. Limits displays a line that shows how far away the camera can see. And this is just for us. This is not for Blender. For rendering, rather. This line will not show up in our final render. It just gives us a hint as to how far away our camera can look. So if I put an object beyond this, I would have to increase my clipping. And if I decrease my clipping, this line gets shorter. This line shows us how far away our camera can see. Mist allows us to display mist in the scene, so if I had mist, it would show up. Name displays a camera name with each camera, or at least it should. Oh, it displays the active camera. That's what we're seeing here. Name displays the active camera. And some few other properties that we don't really care about, safe areas, custom properties. We're mostly concerned with making sure that our scene is visible. There you can see here, this is camera. And if I were to switch, that would be camera 1. So it displays the name of our primary camera. What we really honestly care about is the shifting and the clipping. Being able to rotate our camera. Oh, I have the other camera selected. Being able to rotate our camera without actually changing the camera's perspective. And being able to change our clipping amounts as well as our focus. These guys right here are going to be our most important settings. Now, one thing that I find very interesting, and these safe areas, if you guys want to know more about safe areas, they're in my PowerPoint, which I'll upload to eBackpack. Safe areas basically show some margins that allow us to leave a little bit of a buffer. I guess I can show an example real quick. So if I add safe areas, and I change these title safe margins, these are the areas that I'm saying are okay for text. So if I were to add text to the scene, it should only be inside this area. Action safe means that anything important that's going on should happen within this area. So this outside area is just meant to be extra cutoff. There's a chance that on different resolutions and different displays, we might lose this area. So we don't want to put anything important on the edges of our scene. That's all safe area is showing us is this is the area of action and text, and these areas should be left relatively vacant. One thing, though, I'm going to get rid of limits and name for now. One thing that is really, really difficult, as we've seen, is let's say I want my camera to be focused on this object. So I'm going to change my active camera. I want my camera to stay focused on this cube, but I want to move my camera around. And that becomes really difficult because as soon as I move my camera, now I have to do a whole bunch of rotating and aligning to make sure that I get it where it wants to be. Right now, we are going to talk about constraints, specifically the track to constraint, which allows me to focus a camera on an object. And I really think you guys are going to like this because it means no matter where I move my camera, my object will be in view. So I'm going to go to my camera, and I'm going to go to a new button that we haven't used yet on the button bar. This button is called Constraints, and it looks like a little chain link right here. So constraints are ways for us to add extra specifications to our object. In this case, I'm going to go to my constraints, I'm going to click Add Object Constraint, and I am going to track to, under tracking, see this here? I am going to track to an object, and I just need to select which object I want to target. I am going to target my cube, and it doesn't work. Well, there's a reason it doesn't work. Cameras need to have their to and up axes configured. Whenever we track an object, we should always set our to value to -z and our up value to y. These settings, and I would write these down, guys. Keep this as a shortcut because you're going to need these settings a lot if you're using track to. These settings allow us to reorient the camera in its proper direction. So if I do Z and Y, and then I look, now I can see that I am focused on my cube. Now here's the beautiful part. No matter where I move this camera, it always stays focused on my cube. I move it over here, it's still looking at the cube. I move it around down here, it's still looking at the cube from below now. So no matter what we do, even right here, focused right on the cube. No matter where we move this, it stays where we want it to stay. And that is done using a track to constraint. So that's the last little trick I wanted to show you in this video. It's going to be really handy in your activity for class today because you guys are going to be making a model and then using cameras to display at least 3 different angles of this model. And it'll be really handy if you're able to track to the model so that when you move your cameras around, you don't have to worry about readjusting them. So keep in mind our track to constraint, keep in mind what we can do with shifting and clipping and our focal lens to increase or decrease our zoom. Those are the things we're most concerned about with cameras.